We spent a lot of time discussing how to deal with different units. Now let's define a new type of unit, density. So density is the ratio of a substance's mass to its volume. So we have an equation, density is equal to mass divided by volume. Density is an intensive property, so it is a unique property for any material. Just like we talked about color or conductivity, how you can figure out what that sample of copper is, you can figure out what a sample is based off measuring its density. That's a very common way to determine the density, the name of a piece of metal is by figuring out its density. And the word density, we're kind of used to. Low density means not a lot of stuff packed in an area, and high density means a lot of stuff packed in an area. And generally, in the case of chemicals, what we're really referring to is the atoms, those objects that are making up the substance. So low density means lots of space between atoms. High density means not a lot of space between atoms. Density, in terms of how we experience it determines whether or not things float on each other. So objects with a lower density float on top of things that have a higher density. So this is, we're used to things like solids or objects floating in top of liquids. It also does correspond to liquids. So more dense liquids, like for example, honey, will rest below less dense liquids, like corn syrup. So this tower has been made very fancily using liquids with a lot of different colors and food dye and arranging them. What they have done is very difficult. This is very tedious to accomplish, but you can do this and get this nice separation. And then you can see there are solids that rest at the bottom of whatever the liquid is that they are more dense than. So for example, this tomato that's right here, you can see that this tomato is less dense than the milk layer, but it's more dense than the dish soap layer. So it sinks into the dish soap and then it goes, but it won't sink into the milk. So this nice, beautiful thing, more simpler than that is like ice floats on water because it has a lower density. But this is nice, fancy show off way to do it. A substance occupies a volume of 34.5 milliliters and has a mass of 45.3 grams. What is the density of this substance? We're going to put a slight twist on our first question. We're going to be more generic. What do we want? We're not going to specify units because this is just how we can approach solving problems. So what do we want in this problem? Density. What is the density? And the thing that's good about density is we want to remember is that density has an equation associated with it. Density is equal to mass divided by volume. The whole idea is by figuring out that we want density, by recognizing that density has an equation, we can use this as a framework to solve the problem. Because if we want to know the value for D, the density, it's just a matter of plugging in the mass and plugging in the volume. So this isn't a unit conversion problem, but whenever we have an equation that we can work with, we can ask, how do we solve that equation? Do I have values for the other variables? And that's where I want to start to look at, do I have the mass and do I have the volume of this substance that I can plug into this equation? Substance occupies a volume of 34.5 milliliters and has a mass of 45.3. What is the density? So the thing about densities, this is potentially a new idea, new concept, but the thing when we see that word density, we want to know, especially if we want the density, that density has an equation. Density is equal to mass divided by volume, which we can approximate. D is equal to little m over a big D. Not approximate, but abbreviate. And so this is what we want, right? I want the density. So the question becomes, do I have values for these other variables? Because this is an equation. If I want to know the value for the density, if I can plug in values for the other variables, it would just be a matter of processing that doing arithmetic. And so in this case, we always want to look to the problem. Do I have the mass? Do I have the volume? And so we can see explicitly, we're told volume 34.5 milliliters and a mass of 45.3 grams. So yes, the mass is going to be 45.3 grams, and the volume is going to be 34.5 milliliters. Wonderful. So what I can do is I can just plug those values in. Density is going to be equal to 45.3 grams divided by 34.5 milliliters. And when I go to actually evaluate this, just like we've seen with the unit conversions, what you do is you take those numbers, you divide those out, round for your sig figs. And so we get 1.31 needs to have 3 sig figs. And then we just do the same thing with the units. So it'd be grams divided by milliliters. Those do not cancel each other out. Those are entirely different types of units. We do not expect them to cancel each other out. And that's okay. This just is a compound unit. This is the standard unit for density. So when you're asked what the density is, you would just say 1.31 grams per milliliter. There is no conversion, there is no cancellation, no definition. That is your density. So one of the things we can see is that calculating density just requires measuring mass, which generally we can do that relatively straightforwardly in the lab, and volume, which those are two measurements that we do for a lot of different things in the lab that aren't too difficult and don't require like technical equipment, which is why density is a really common thing that we measure to characterize substances. Calculating densities like that is really useful for determining the identity of substances. So, it's relatively straightforward to measure mass and volume of an object because you can use readily available lab equipment. And so it doesn't require a lot of technical skill. It's also not destructive. You don't have to break apart the object. And so if you have, say, a sample of metal and you want to know what it is, you can figure out its density by measuring the mass and measuring the volume. And that is how we identify a lot of things, because you can just look at tables of here's just a sample of a couple of metals and a couple of liquids and see what their density is. And you can see they cover a nice range. And metals really allow you to, aluminum and iron, for example, look relatively similar. They're both kind of shiny, silvery. But you can see their densities are really different, right? 2.7 and 7.8. That's very, very different from each other. And so it's very easy to distinguish those. It's not like you're having to make really, really tight measurements, and you can get that figured out decently well. We can also see, ice has a lower density than water, hence ice floats on top of water. You can also use, nice little quirk, Diet Coke has a lower density than Coke, and in fact, Diet Coke has a lower density than water. So Diet Coke floats on water, and regular Coke or any sort of real soda without, full sugar soda is going to sink in water because sugar is really dense, whereas artificial sweeteners are not very dense, and so they make the soda less dense than water, so it floats. So these sorts of properties, these sorts of experiences are all based around the density of that material that we observe. So those are nice properties of that, of how we, kind of can experience density and the importance of understanding density. We also want to take a look at an example of how we functionally use density in understanding and analyzing material. So the density of ethyl alcohol is 0.79 grams per milliliter. What is the mass of 125 milliliters of ethyl alcohol? We can always start by asking what units do you want? What are we looking for our answer? And if we key in on the problem, we can see what is the mass. So we want some sort of mass. We can see elsewhere in the problem that grams are mentioned. There's a G, so grams would probably be a reasonable mass unit to end up with, but really, it says what is mass? As long as it's any type of mass unit, you'll be fine. So what units do you start with then? And here's where we can see this is a little bit of a complication because we have two numbers that have units associated with them. And so the question is, which one of those are we going to use to kind of turn into our mass? And what we can think about is Mass is an extensive property that is a characteristic of how much stuff you have. So if we're going to be doing a unit conversion or a relationship, we're probably going to be starting with another unit that is extensive and describes how much you have. That's going to be my 125 milliliters. We can also see that mass, if it's grams, that's not a compound unit. That's just a singular unit. So 125 milliliters is what we're going to use. It's very tempting to want to start with this grams per milliliter. I don't know why, but people want to start with the grams per milliliter. That is a compound unit. You are not going to convert a compound unit into the singular unit of mass. So the units that you're going to start with, you want to know what's the mass of ethyl alcohol? That's a question of how much you have. You're going to start with a similar description of how much ethyl alcohol do you have. It's just going to be the volume description and not the mass description. The density then comes in as a conversion factor. Density is the formalism that lets you relate these things. Density is a material-specific conversion factor. 0.79 grams per milliliter. It's a relationship between mass and volume. We can then use that to do a conversion relationship. You still also can use the density equation if you prefer that method. We're going to use other conversion factors like density where you don't have that choice, but here we have the choice, kind of a relationship. So we're going to do both ways to solve this problem. You're going to get the same answer. They're just two different methods. We'll see how they go. Density of ethyl alcohol is 0.79 grams per milliliter. What is the mass of 125 milliliters of ethyl alcohol? All right, so in this case, we're going to look at solving this problem in two ways. So there's going to be more than one way to do this. So the first one is we can set it up like our equivalent, our unit conversion problems. We know we want mass. We can use any mass unit we want. We can see a G in the prompt, so it is likely that what we want is grams. And so then the question is, what are we starting with? And the complication here is that we have two units. But grams, we can see, is a single type of unit. There's a big temptation to use this because it already has grams in it. We think that's where we'd start with. But instead, we want to focus, we're starting with this. Grams is an extensive property. It describes how much stuff you have. Volume is also extensive. It also describes how much stuff you have. So as a result, we would say that that's what we want to use, right? We want to use the 125 milliliters. Another note, we're going to see here that the compound units on the grams per milliliter are an indication that that is actually a conversion factor. So in this case, we have a nice, single unit that's going to be converted to a single unit. And when we look here, we would think, hey, milliliters needs to go down there, grams needs to go up there. And I'd be able to do that relationship. My milliliters would cancel and I'd end up with grams. Wonderful. Milliliters would cancel and end up with grams. So the question becomes, this needs to be a conversion factor. So I need to put in some numbers there. So how many grams are equal to how many milliliters? And so we've seen previously that it becomes kind of this question of, well, how are these things different? Well, gram and milliliter, they're both metric units, which is great, but they measure different things. Grams measures mass, milliliters measures volume. There is no general relationship between those two. They're entirely different ideas. But for ethyl alcohol, our relationship is right here. So when we see this written out, that we have 0.79 grams per milliliter means that it is 0.79 grams per 1 milliliter. Which means that we have an equivalence of 0.79 grams of ethyl alcohol is the same thing as 1 milliliter of ethyl alcohol. Now, this relationship is only true for ethyl alcohol, for the substance that we're looking at. A lot of times when we're doing the work, we don't necessarily, we just write grams and milliliters to save on some space. But technically, this is only true because we're dealing with ethyl alcohol. So we can always use density in this way, but the value is going to change. So when we go to look up here, this would be 0.79 for our grams and 1 milliliter. So we can multiply that out, 125 times 0.79 divided by 1, but we want to be careful. How should we be rounding this? That's 3 sig figs on your 125. 0.79, that's a leading zero. Zeros in the front never count. That's only 2 sig figs. The 1 on the milliliter, it is per milliliter. Per always leads to that thing being exact. So our answer should have 2 sig figs, 99 grams. 125 times 0.79 divided by 1. So this is a unit conversion method that we can see that density is this property that you can use to identify what a substance is, but you can also use it to relate different quantities of a sample. You know the volume of the sample, well, what's the mass? Ethyl alcohol is a liquid. It is relatively easy to measure the volume of a liquid. It's kind of a pain to measure the mass of a liquid, so you can just measure the volume and then use this relationship, use the defined density just to figure out the mass. You have saved yourself from having to do an experiment that's potentially more difficult. So you can do an easy measurement, or not necessarily easy, but more straightforward measurement, and get an answer for a more difficult measurement. In this case, mass of a liquid. Not impossible, but is more difficult than measuring the volume of that liquid. So density is really useful in this way to do this relationship. I do want to show another way to work through this problem. This is a unit conversion based approach that I think is very clean because you just have this one relationship that you're coming from. But some people prefer a more algebra based solution, and that works as well. Whenever we are given density, we have our density equation. So there's kind of some additional flexibility that comes from that density equation. And we can similarly ask, which variable in this do we want? Well, what we want is that mass. Okay? So do I have density and do I have volume? And we can see, yes. We saw the density was 0.79 and the volume was 125. So what we can do is we can plug those values in. I get 0.79 grams per milliliter is equal to whatever my mass is divided by 125 milliliters. So what I can do is I can multiply both sides by that 125 milliliter. These cancel. And I'm left with 125 milliliters times 0.79 grams per milliliter is equal to my mass. That should just cross that out. My mass. So my math, so you got it right the first time, right? I can multiply these two numbers. These are still, I need to consider sig figs, 125 times 0.79, the same values, 3 sig figs, 2 sig figs. I get 99. And then for the units, I can see it ends up being milliliters times grams per milliliter. And so just like we saw previously, Those milliliters cancel out, and I get 99 grams. Which matches what I got up here. 99 grams from the unit conversion, 99 grams from the algebra. Either of these relationships are either of these approaches are totally acceptable, especially because they both give you the right answer. So you can feel free to use whichever one you prefer. Sig figs are still the same. The actual arithmetic you're doing is the same. It's 125 times 0.79. So it divided by 1. And so you get the same number. So either way works. It's just a matter of whatever you are comfortable with. Again, there's no right or wrong way to solve any of these problems. There are right and wrong answers, and there are easier or more efficient ways to do things. But as long as you're showing how you're trying to accomplish something, that's an acceptable method.